Good morning, dear students. Hope you are doing well and following all the lessons in a good understanding manner. Coming to today's session, as we are in second unit discussing topic image enhancement. Here, image enhancement. Hope you understood well why we are enhancing image. In the first unit, when we have a look, you understood how the image of the target will be scanned by sensors. In the second unit, as per your curriculum, we are discussing how the images will be interpreted by the analysts. The moment we enter in second unit, we discuss there are two methods. One is visual image interpretation techniques, or else elements of visual image interpretation. There you discuss how the spatial information or the spatial data will be interpreted by the analysts with the help of key elements. Hope you understood that concept very well. Based on the key elements like size, shape, shadow, pattern, association, tone, texture, sight, we are able to analyze the data. After this topic, we are entered into the digital. In the previous instance, based on the key elements, the analyst used to interpret what type of object it might be based on by seeing the spatial data. Here, as we are discussing digital image processing, it is mandatory to remove certain flaws and errors which may occur because of the atmospheric influence, as the EMR, which holds the image of the target traveling from sensor to target, target to sensor. That is why we need to remove those errors, and it has been categorized by name image pre-processing, in where two types of errors we have seen: radiometric correction and geometric corrections. Hope you are well content about this radiometric correction. The previous class and also on complete class we discussed about this radiometric corrections, where we have seen four types of methods. How can we remove the flaws, like removal of missed scan line, destripping, random noise removal, sun angle and topographic correction, atmospheric correction. Here, the geometric correction, which may occur because of the errors of the instruments. Geometric corrections in that sense nothing but correcting the images with respect to shapes, curves and scales, I mean projections. These may occur because of all those four reasons we have seen. This is already we discussed, but why I am discussing before we are going to today's session is there is a link, and it has to be feed you. It has to be discussed as in a warm-up schedule, as in a warm-up discussion before we are entering into the today's topic. See here, in the geometry correction, we have seen scan, skew, systematic correction. Scan, skew. What is the meaning of skew here? Nothing but it's in a right angle. Skew, the literal meaning of skew is parallel, or as parallel, or as at right angles. In this right angle, in this context, scan, skew means we can discuss this particular word here at right angles. Scan, skew. The scan has to be done at right angles, but because of the forward motion of spacecraft, the ground swath is not matched to the scans. I mean, the swath is not matched to the ground track. This is one type of technique to correct the issue. Non-mirror veracity variations we have seen. Non-systematic corrections. Under non-systematic errors, we have seen image to ground geocorrection, image to image geocorrection. All these we already discussed. That's why I'm not discussing again here. See here, miscellaneous pre-processing. We have seen subsetting, spectral subsetting, and mosaicing. And now we are here, image enhancement. Here we have seen two operations, point operations and local operations. What is point operation? What is local operation? You already aware. Coming to the topic, the title is image enhancement. How you can enhance? For suppose, if you captured an image of one person or any place, there are multiple options in the window. You can crop the image, you can increase the contrast, and you can add anything in a meaningful manner for better appearance. In the same way, image enhancement, image in the sense what here? Image in the sense nothing but target, which is scanned by sensors in the form of electromagnetic radiation. We are just enhancing image. Why? Enhancing in the sense improving, image improving. You can talk, don't write like that, but improving the image quality. For improving the image quality, you can apply two types of operations. One is point operation, the other one is local operation. Point operation in the sense, you are just changing the value of digital number without any concern or without any consideration of neighboring pixels. Local operations in the sense, the changing of values with respect to the RS by considering neighboring pixel values. Image reduction we have seen in the previous class. Why it is needed? Because in remote sensing, the satellite data, the spatial data is large in volume, that means size, of course with respect to resolution also. That is why it is may not be compatible in normal computer screens. In such cases, the data has to be reduced. How can you reduce? And how much you can reduce? That's what we discussed yesterday itself. How much? In the sense, it's based on the requirement. You are reducing the time. Reducing the time schedules. You are reducing the academic calendar of your own to prepare for something else. You are reducing the burden of preparing if you prepared well before exam, far before examinations. That means you are reducing what? The data. How much? It depends on the requirement. For instance, we have seen 2x reduction, where in an image, you must draw this image, and here you are not supposed to draw as your wish. You must use neat. You must use neat pencil, that is nice pencil, and you must use a scale, and you must represent the numbers with pencil, preferably 2HB pencil. Hope you know if you are not using, you're not following the precautions, what the consequences will be, because you may not get the good marks. This is what even yesterday we have seen. 2x reduction, every second line is reducing here in the direction of columns as well as in the direction of rows. See here, 6 columns and 6 rows are there. It is reduced to 3 columns and 3 rows. It is 2x reduction. Followed by magnification. What is the magnification here? First thing is optimum utilization of available color display scale. So you want to increase the color, display mode. How can you increase? Based on the availability of. If you want to add color for one particular structure, how many colors you are using to one particular structure, that depends on the availability of colors. Am I right? In the same way, when you are magnifying the image, that must be within the range of, or else as per the display scale of the device. That's what you wrote out there. That's what we are on Windows is visualizing here. For the improvement of display scale for enhanced visual interpretation to match the display scale of another image, of the same image. If it is not well, and based on the other image, you are considering you are increasing the resolution in such a way you can interpret the characteristics. Here one more word also there here, image magnification. You are magnifying, have an image in your mobile phone, and if you are to enhance one particular part, what you used to do? Zoom in. And the reducing means zoom out. The other name of image reduction and image magnification. Now, this is what we already discussed, 2x magnification. Here in the previous instance, here 3 rows and 3 columns. Now here, same, the 3 rows and 3 columns are magnifying to 6 columns and 6 rows as it is 2x magnification. Every column is replicating towards column direction and towards row direction. That's why you have 6 rows and 6 columns here. And how much you can magnify, that's also depends on the requirement to perform the particular task. This is what about magnification and reduction under image enhancement. Okay, now contrast. What is this contrast? The range of brightness values present on image is called as contrast. Now, what is contrast enhancement? Making an image stand out more clearly by making optimal utilization of available colors on the display output device. I told you with an example. See, you want to color a structure. How many colors you can select? It depends on the availability of colors. If only 2 colors are there, you can go for only 2. If number of colors are there, you can go for the more choices. What I'm speaking is here, the contrast enhancement means contrast enhancement means it is a process which makes the image features stand out more clearly by making optimal utilization of available colors on the display device or else output device. Here contrast involves or else contrast process involves change of brightness values. are changing the original values. That means you are increase if you are increasing the digital number value, that means the old number was erased. The old digital number is, for suppose 0 to 255. 0 is dull and 255 is high brightness. If you want to increase the value from 5 to 10, the original value 5 is erasing. That's what this point is speaking to us. Contrast manipulation was changing the range of image values to increase contrast. Then why we need this? When the images are scanned with low dynamic contrast, where you can't find out the characteristics of the image more clearly, there you need to go for it. Low dynamic range, where you are unable to visualize more clearly, there you should go for it. Enhancement. Low dynamic range, as well as whenever the requirement is there with respect to increase the contrast, we can adopt this enhancement procedure. Before understanding this contrast, one has to know about histogram. What is this histogram? Here, see here, graphical representation. What is contrast? The range of brightness values present on an image called as contrast. Here, range of brightness values in graphical representation that holds an image is called as histogram. In the previous case, the range of brightness values, in this case, range of brightness values in graphical representation that holds an image is called as histogram. See here, this is histogram. Here, the range of brightness value of this particular image is 0 to 255. The image exists in this as below this graph, as below this space. This is what about image histogram. Coming to types of contrast enhancement. There are two categories of contrast enhancement. One is linear contrast enhancement, where the histogram is linearly expanding by replacing the original values with new values of distribution called as linear contrast. Linear contrast enhancement is the process where the histogram is expands linearly by replacing the existed digital values with newly distributing values. Here also, while the histogram is expanding, it makes or else it utilizes the available or else total range of display device resolution. Expanding histogram in the sense changing of digital numbers. What is histogram? Graphical representation of digital numbers or as brightness values is called as histogram. Once the histogram is altering, how can we alter? By changing the digital number values. The caution is the digital number values can be changed or as can be utilized or as can utilize total range of display device resolution. While it is expanding, it utilizes the total range of display device. There are different categories under linear contrast enhancement. We are discussing two under this category and two under nonlinear contrast enhancement. That's what enough as far as your syllabus point of view, because the title is image enhancement. Under image enhancement, you must learn all these things. Okay, right. Here, the first one is minimum maximum stretch. Minimum maximum, the title itself revealing to us there is a word minimum and there is a word maximum. What is minimum and what is maximum here? See here, for everything, that is for most of the things, we can go for minimum and maximum. Your faculty may allow you to write your examinations of slip test as a classroom test, not an external exam. He may allow you if you are late for 5 minutes. And he may not allow you if you're late for 40 minutes out of 50 minutes examination. Are you with me? That means minimum he can allow you up to 5 minutes if, and he may allow you maximum 1 or 2 minutes more, because you are, if he allows, you may not complete the exam within the stipulated timings. What I'm speaking is here minimum. What is the minimum energy you needed? What is the minimum fare to go to so and so area? Maximum also there and minimum also there. When coming to this contest, what is minimum and what is maximum? The maximum is 0 to 255, the whole range of brightness values. Now, see here, the second point, the first point already we discussed. The second point, I mentioned one particular example. Consider an image which has a brightness value of 55 and a maximum value of 250. In that image, what is the display scale minimum and maximum? 0 to 255 in normal computer, normal remote sensing applications. For this, for one particular image, the minimum value is 55 and the maximum is 250. In these constraints, if I want to expand the contrast, if I want to change the contrast, I can go for 55 to 0, and here I can go for 250 to 255 as there is a availability, so that I can get the image more clarity. I can visualize the image more clearly. See here, have a look over here. This is the image before enhancement, minimum maximum. Here I said that consider an image 54. Here is the 54 and here is the 215. This is what the image. I want to enhance the image. What I can do is simply I can expand from 54 to 0 and 215 to 55 so that I can visualize the image more clearly. What we are discussing? Contrast enhancement we are discussing. Under contrast, what is contrast enhancement? Stand out the image more clearly by making optimal utilization of available range of colors in the display device. What is the availability here? You can go for even up to 0 for minimum. You can go for up to 255. That is the availability. If I go for this, I can get the image more clearly. This is what about minimum and maximum stretch. This is minimum and maximum. I can't go beyond 0. I can't go above 255. This is the minimum. This is the maximum, and this is the minimum. I can get the image more clearly. That is why we mentioned, we call this by name minimum maximum stretch. Stretch in the sense, stretch. We are just stretching from this end that end so that I can get the image more clearly than before. The next one is saturation stretch. Saturation. What is saturation? You know what is saturation very well. It's, in general terms, we can discuss it as a range of patients in general terms. Saturation, over limit. Your faculty allowed you to the class, even you're late for 15 minutes, by saying tomorrow please make sure to come within the timings during normal days. Not all these special, not all these type of days what the world is facing. And tomorrow also, the next day also, it's, you did the same thing. Again, you late for 15 minutes. And you are repeated next day also. And next day also. When the days are moving, you are increasing the time. First day, 15 minutes late. And second time, 20 minutes late. Third day, 25 minutes time late. That means by seeing one particular time, your teacher may get saturated stage with respect to allowing you to the class. Because even though in spite of many times of reminding and insisting regarding timings, you keep on late, which is not good. For one particular point, you are making teacher to irritate or else to disturb the class every time. Why teacher get irritated? Because if you are lating every day, every time you are entering, may get disturbance. But your teacher has seen you almost from 1 month. Come within the time. That means one saturated timing will be there. There you are losing your attendance. If you are continue like this, as you are late 15, 20 minutes, 30 minutes, 40 minutes, 50 minutes, the first hour is over. That means you may lose. You are unable to enter to all the first hour classes. You are losing the attendance. You must face the consequences. What you are facing, what you may face, that you know. What I am speaking is here saturation. For everything, there is a saturated stage. In terms of our civil engineering, you maybe hear the word surface runoff. What is surface runoff? This is a particular prospect. I just discussed the example in a general perspective. What is saturation with respect to the education, with respect to the classroom teaching? In a particular perspective of our civil engineering domain, what is saturation? You might have heard the word surface runoff. Runoff from where? Surface. Which surface? From the ground surface. During heavy rainfall, uh, during heavy rainfall, the soil reached to saturated stage of absorbing water, and it won't absorb the water if the rainfall is continuing. In such cases, whatever the water falling down on the surface simply simply it moved off from the surface of the ground, which we used to call it as surface runoff. That means the soil at that particular area is in saturated stage with respect to absorbing water. That's why we used to observe the water is flowing even from the open ground or from the surface of the ground. Normally, where we used to observe this phenomena from the concrete roads, water may flow naturally. But whereas on empty ground, water will be absorbed. But it is not happening because the soil is already saturated stage with respect to absorbing water because of heavy rainfall. And whatever the amount of that is falling on that particular area is slowly moving off. That is called as runoff because of the saturated stage of the soil with respect to water. In the same way, here saturated stretch or a saturation stretch or percentage linear contrast stretch. What it is? Simply, in remote sensing images, when we are discussing about the histogram, we discussed about a graphical representation of brightness values of an image is called as histogram. Most of the cases for remote sensing images, the tail ends of the histogram. What are the tail ends? These are the tail ends. These are the tail ends may not have the image what is required. Most of the cases, the image may lies here itself, the center portion. The tail ends may not have the required area. In such cases, to enhance, what is enhancing? Changing the brightness values. In the previous case, what we have seen, the minimum 54 we have taken, 54 to 0 and 215 to 255 we have expanded. Now what we are doing here, not minimum and maximum. I just conforming or I just taken one decision, right, with respect to the percentage. What is the percentage here? See here, a very few pixels at two ends of the histogram occupies reasonable amount of brightness values, and these tail ends are trimmed, and the remaining part of it will be enhanced. See here, the remaining part is enhancing. If you are not trimming, where I can enhance, because the histogram is up to 0 to 255 here, 0 to 255 here also. But the image is there here itself. In such constraints, I will take a decision, the tail ends up to percentage based on the image that has recorded. The tail ends are trimming. Why I am trimming? Because in most of the cases, the images lies in the center portion of the histogram, or else in remote sensing, the tail ends may not hold the required portion of the image. In such cases, not every time, in such cases, here, in which case, such case in the sense which case? Here, this case 54 and 215 here. This is histogram. But here, there is no possibility. The histogram is from minimum to maximum here. But here, the minimum is 54 and 255 is 215 is maximum. There is space, so I just went for expansion. But here, when you have a look here to here, it occupies whole range. In such cases, as the tail ends may not hold the required portion of the image. In such cases, for enhancing the image quality, I can trim the tail ends, and after trimming, the histogram will be expanded 0 to 255. This type of expansion is called as saturation stretch or percentage linear contrast stretch. Understand? It is similar to the minimum maximum linear contrast stretch. This method uses a specified minimum and maximum values that lies in a certain percentage of pixel from the mean of the histogram. That means this method specifies the minimum and maximum values that lies in a certain percentage of pixels. Minimum and maximum values that lies in a certain percentage of pixels. Minimum and maximum values that lies certain percentage of pixels. This method is speaking. This method uses a specified minimum and maximum values that lies in a certain percent of pixels from the mean of the histogram. Mean in the sense by seeing the digital number values here, as most of the cases after analysis, the range of brightness values at the tail ends, we are trimming and the remaining portion will be enhanced so that the image will be more clear than before. This is what about non-linear this is what about saturation stretch or percentage linear contrast stretch. I said that there are different categories under linear contrast enhancement, different methods. We are discussing two, and non-linear will discuss two. That's enough as per your syllabus point of view and time boundaries point of view. Okay, see here minimum and maximum stretch, saturation stretch we have seen. In nonlinear contrast enhancement, the histogram is linearly expands here, expands original digital values of spatial image data into new distribution we have seen. Now what is nonlinear contrast enhancement? See, when the histogram is asymmetric in the sense zigzag, the values are up and down, up and down, up and down, asymmetric. In such cases, the linear contrast enhancement is not possible. When you have a look here, the increase is gradually increase and gradually decrease here. That's why we have opted linear contrast enhancement. But here, in the nonlinear, the histogram is asymmetric, so the linear contrast enhancement is not applicable and not adaptable. It involves an algorithm, a formula to change the histogram. Here also, when we are adopting this category or as this method, the old values are replaced permanently. Old distant numbers will move off permanently. Under this nonlinear contrast enhancement, we are discussing two categories. One is histogram equalization and reference stretch. There we have seen minimum and maximum stretch, and the second one is saturation stretch. And here we are discussing two more. One is histogram equalization followed by a reference stretch. Here you know what is histogram and what is equalization. By seeing the word, you may have a general idea. What is that we are going to discuss. Then why we are adapting? When the histogram is asymmetric, we are adapting this. How can perform this? By using algorithm and formula, we can change the histogram properties. It here it transforms histogram of any shape to histogram which has same frequency along the whole range of digital numbers. It transforms a histogram of any shape in this type equalization. It transforms any shape of the histogram which has the same frequency along the whole range of digital numbers. It can change any type of or as any shape of histogram. The shape of histogram depends on what? The shape of histogram depends on the digital number values. Am I right? If the digital number values are low, slowly, if digital numbers values are high, slowly it rises and falls. That's what we have, input brightness values. This is what. Okay. See here, whenever the image histogram is equalized, all the pixels values of image are distributed. It can change any shape of histogram. Whenever the process is applied, it changes the brightness values of histogram and redistribute with new pixel values. It reduces the contrast at light and dark parts of the image. Obviously, when it reduces the light and dark spots of the image. How? See, have a look over here. This is about equalization. This is the image. This is the image. See here, and this is redistributing like this. The first one, it can change any shape of histogram, which is which has the same frequency along the whole range of digital numbers. It has same frequency like this, high and low frequency. It can change any shape of histogram, and it can change digital numbers which has the same frequency along the whole range of digital numbers. Now what it is doing after doing this image, the dark and light, see here, dark and light parts contrast will be reduced. It is the dark. Now what I am doing, I just expanding the contrast. How I just making this image equalizing from here to here, similar pattern. This is what about equalization. How can I perform? By adopting a formula, by adopting an algorithm. We used to change the histogram. Understand? And now here, reference stretch. What is reference stretch here? You, by the name itself, you can understand reference. That means something is referred. You yourself are referring someone to get a rank. You are motivating yourself by taking your friend as a reference to get a rank, as to get an admission in a good premier institution for masters. What I'm speaking is a reference. Stretch, you know. Stretch in the sense nothing but expanding. The image of one particular scene which has taken earlier or else different images of same scene captured at different timings, at different days, are compared with a reference by taking one as a reference. Understand? In simple perspective, in simple discussion here, histogram of image resembles to the histogram of another image. Histogram of image, what is histogram? The range of digital numbers, graphical representation of brightness values of image. One histogram resembles with the histogram of another. How can I? Simply, one image is being compared with the other image histogram which was taken earlier and which has taken at different timing than this. Understand? Or else one copy of one data, or else the data of the similar scene or same scene you are using, or else you are keeping as in a file, and the fresh one is comparing and just making histogram, or just stretching the histogram by visualizing, or else by keeping view of the other histogram of the other image. Understand? The histogram of one image is stretching with the histogram of, like with one histogram of one image is modifying or is stretching. Histogram of one image is stretching or is resembles the histogram of another image. How we can achieve this? Simply stretching the histogram of the image by keeping view of the histogram of another image which has taken at different time, that is different days, which is already stored as file copy. Hope you understood what is this reference stretch. When you have a look over here, in the linear contrast and the contrast enhancement, there are two categories. One is linear contrast enhancement. In that, there are two we discuss because of the time boundaries: minimum and maximum stretch, saturation stretch. If you have a time, we may discuss few more, but up to here, that's okay as per your syllabus point of view and curriculum point of view. Two in linear contrast enhancement, two in non-linear contrast enhancement. Among them, in the linear contrast enhancement, the one is minimum maximum stretch, the second one is saturation stretch. Under non-linear contrast enhancement, we have seen histogram equalization and a reference stretch. Today we discuss about a brief introduction about image enhancement, image magnification, image reduction, and full-length class about contrast enhancement. Under contrast enhancement, the two categories, linear and non-linear categories. Under linear, two more categories. That means as the linear contrast enhancement is divided into two categories, non-linear contrast enhancement divides into two categories. In the next class, we'll discuss about the other method through which the image will be enhanced. If you have any doubts, please contact me in the domain, whatever you feel convenient. Thank you.